In this example, we have to use the previously discussed equation 16x squared plus 24xy plus 9 squared plus 60x minus 80y plus 100 is equal to 0, and find the equation pertaining to the rotated axes, as you can see here, right? So the entire system, entire old axis is rotated, and we discussed that the angle was about 37 degrees, okay, in order to eliminate the xy term in the original equation. Right? So we have to find the actual equation itself, the equation that we're going to use to plot or to draw the graph in the new axis system that you see here. So I indicate the 37 degrees, about 37-degree rotation of the new coordinate axis system, and we have to find the respective equation that will help us graph this equation in the new system, right? And we found in the previous video the coordinates of this curve to be plotted here. We found the old coordinates in terms of the new coordinates, right? So in order to find the equation, the new equation, we're going to have to express this equation in terms of x primes and y primes, right? And for this reason, we're just gonna substitute the x's and the y's into this equation so that everything on the left side is going to be in terms of the x's and y primes, so that we can use that to draw this curve in the new axis system. All right, and I'm going to explain to you at the end why am I using this and what this means on the right side. So first, let's do the work. So we're going to take 16 and we're going to put x squared in terms of the x primes and y prime substitution, right? So that's going to be 4x prime minus 3y prime divided by 5, right? That should be clear. Plus 24xy. Now xy, yeah, I know it's tedious, but you're going to have to do this, right? This times that, right? Because that's the xy product there. So that's going to be 4x prime minus 3y prime divided by 5 times 3x prime plus 4y prime divided by 5, okay, plus 9y squared, right? So we're going to have to square this thing. So I'm just going to put it as squared. I'm not going to repeat it. Plus 4y prime divided by 5 being squared. Then plus 60x, right? That's just this, right? So 4x prime minus 3y prime divided by 5 minus 80. The y is here, right? So 3x prime plus 4y prime divided by 5. Almost done. Plus 100 is equal to 0. Good. So now we have to just simplify, right? This is a lot of simplification. So notice that all of these guys, and I forgot to square it, right? 6x squared, so this should be squared. So all of these guys have a 25 pretty much as their denominator, right? This product is giving you a 25 in the denominator. This one is squared 25, right? This one is squared 25. This one's not, and this one's not, but we're going to work it out. We're going to work it out. So let's put 16 over 25 outside. And here what we should have is just the top being squared, right? Because we already took the bottom out. So that's going to be 16x prime being squared minus 24x prime y prime plus 9 prime squared, right? So that is instead of this, all right? Plus 24 over 25. So again, I'm taking the 25 out, so I'm going to have here 12x prime squared. Now, I just did the top using the FOIL method. I got this, 3 terms, right? The trinomial as a result of squaring the binomial on the top, right? And the same thing I'm going to do here. So I'm getting the first product in the FOIL method, 4x prime times 3x prime, and etc. The outer, the inner, and the last product. So the simplified version is going to be plus 7x prime y prime minus 12 y prime squared, okay? Now the third product plus 9 over 25. I'm going to take the 25 out again. So I'm going to have just to square that. So that's 9x prime being squared plus two products of these. So 24x prime y prime plus 16 y prime being squared. All right. Plus, now how do we get this to be 25? If we multiply this by 5, we can do the same thing on the top. So as a result, this will be 5 times 60 is 300, right? 300 over 25. You see how that's done? 5 times 5, so that I get a 25 in the bottom, but then the top has to be multiplied by 5 as well. Otherwise, it's not going to be algebraically true, right? So 60 times 5 is 300. Now that's good. 300 over 25 is exactly 60 over 5. That's the same thing. So then just copy that down. 4x prime minus 3y prime. And then minus, now the same thing here. 5 times 5 is 25, so this must be multiplied by 5. So minus 400 over 25. And this, just copying this over, 3x prime plus 4y prime plus 100 is equal to 0. Plus 100 is equal to 0. Okay, this is long, this is lengthy. But now we're going to just simplify this, right? Notice that we can take the 1 over 25 out. We can take that out because 1 over 25 is common to all of these parentheses here, right? 1 over 25 can be taken out. That's the GCF of these constants, or coefficients rather. So then we can start with x prime. Okay, well rather x prime squared. Let's take that out first. So I'm getting 16 times 16, right? So that's 256. The next one is 12 times 24. That's 288. The next one is 9 times 9, so that's 81. And that's it, right? There's no more x prime squared. So close. Plus, now let's talk about x prime y prime. X prime y prime. We have negative 24 times 16, so that's negative 384. Plus 24 times 7. That's 168. And then 24 times 9, so that's 216. All right, next one is y prime being squared. We have 16 times 9, so that's 144. We have negative 12 times 24 is minus 288. And then we have 16 times 9 for the y prime squared. So that's 144. One more 144. Notice some of these will be gone, which is good, right? Some of these will be 0, so the whole thing would be gone. But let's finish it up before we make conclusions, before we draw conclusions. So x prime, let's see what x prime does here. There's no x primes here, so we're done with that. Now x primes are going to be here. Well, no x prime here. Good. Only here and here. So we're going to have 4 times 300, so that's 1200, minus another 1200, right? And notice this will be gone as well. That will be 0. Good. Plus y prime. So y prime, we have negative 3 times 300, that's negative 900. And here we have 4 times negative 400, which is minus 1600, right? Okay, so we can close the bracketed parentheses because that's where we opened it originally. And that's plus 100 is equal to 0. Okay. I know this is lengthy, but it's still solvable. It's solvable pretty much. So let's see which ones are gone. This one is not gone. This one is going to be gone because this thing is equal to 384. 384 minus 384 is 0. Bingo. We can cross it out. This one is also gone. 144 plus 144 is equal to 288. Minus 288, bingo, boom, gone, gone. And this thing is not gone, right? So this is going to be much simpler now. So 1 over 25, we're going to have, what is this going to be? This is going to be 625. 625 x prime squared. And this is going to be minus, right? Because the result here is going to be negative, right? And this is going to be minus 2500 y prime, bracketed parentheses closed, plus 100 is equal to 0. Okay? So as a result, we can actually simplify this further. 625 divided by 25 is 25, right? So we get this 25x y prime. And 2500 divided by 25 is precisely 100, so minus 100 y prime plus 100 is equal to 0. So now, if you divide both sides by 25, you should get further the answer, right? Divide both sides by 25. All of these numbers are divisible by 25. You get x prime squared minus 4y prime plus 4 is equal to 0. Okay? So now what I want to do, I want to solve this for y prime. So if I solve this for y prime, I subtract basically x prime squared, I subtract 4, and then I divide by negative 4 after that, and then I get this result. Y prime is equal to 1/4 x prime squared plus 1. So there we go. So we found the equation. This is the equation that we can use to draw the curve in the new coordinate system, the rotated coordinate system in blue here. Okay? So now, as you can see, this is much easier to draw than this, right? We know that this equation represents the same curve in the same position that we're going to draw, but this is really crazy the way it looks. This looks way simpler, right? This looks like this is indeed a parabola that you recognize, right? 1/4 x squared plus 1. And instead, just think about the primes not existing there, right? It's just going to be 1/4 x squared plus 1. This is the parabola. This is the parabola with vertex 0, 1 in the new coordinate system, in the rotated axis system. So we know 0, 1 in the old system was here. So if we shifted the vertex, the lowest point of this parabola, since it's opening up pretty much in the new system, if you turn your head a little bit and imagine that this is vertical and this is horizontal, you know that the vertex should be about here, right? It's just slightly rotated from the old vertex of 1 here on the y-axis. So you know that it's going to be a parabola. But now, why do we need these? These are representing the x and y coordinates in the old system, right? And how do I do that? I'm trying to see where the curve hits the y-axis, all right? I'm trying to see where that is, okay? So to do that, I just set x is equal to 0, right? Because on the y-axis, x is equal to 0. So if you use the old equation and set x is equal to 0, this term is gone, this term is gone, this term is gone. So the only thing that remains is 9y squared minus 80y plus 100 is equal to 0, precisely that. So that is solvable only by using the quadratic equation. If you use the quadratic equation, it's going to give you two solutions, right? It's going to give you two positive solutions, okay? Two positive solutions. So if you get two positive solutions, it means you're talking about the parabola going outside of the y-axis and also returning through the y-axis again to go up, right? So basically what I'm saying is that it should go out of the y-axis and then again past the y-axis again. So it should pass the y-axis 2 times because we're talking about two solutions for the y when x is equal to 0. Right? So there should be two solutions. I'm not giving you the precise solutions. They may not work. Right? I'm not saying that the solution is between 1 and 2. I'm not saying the solution is between 5 and 6, right? This is not really required here. I'm just telling you that there will be two solutions. If you want, just experiment, solve this by hand, find the two solutions using the quadratic formula. You're going to see that you're going to have two intersections with the y-axis of this parabola, right? The parabola will intersect the y-axis twice. However, does it intersect the x-axis though? You might think maybe it does, maybe it doesn't. Well, to check, just set y is equal to 0 because x is on the x-axis, y is always 0, right? When you set y is equal to 0 in the original equation, this term goes away, and so does this one, right? So what you have is only the x's. 16x squared plus 60x plus 100 is equal to 0. Now, the thing about this is that when you're going to try to use the quadratic formula, you will have no solution. Why is that? Because the b squared minus 4ac, the discriminant is going to be less than 0, right? B squared is going to be 60 squared, right? That's the b value. 60 squared is 360, right? B squared minus 4ac is equal to 3600 minus 4ac. A is 16, and 100 is the C value. As you can see, this is greater than 360, right? So it's going to be less than 0, right? So for this reason, there's no solution. So that means, what does that mean? That means that the parabola does not hit the x-axis. It does not only doesn't pass it, it doesn't hit it, right? It doesn't intersect it. It doesn't hit it and go back up. It doesn't pass it, doesn't hit it, does not touch it whatsoever. Since the discriminant is less than 0, there's no solution. So that means when y is equal to 0, there's no solution for the x. The x is never passed, never intercepted or touched by the parabola. So we can safely say that we can just pass the vertex, go up, and we will be fine. It's not going to hit the x-axis. All right, so this is the reason why I wrote these two equations, so you can see why they're useful to find the other points besides the vertex here in the new axis system, in the rotated system. But I hope this was useful now that you probably know how to find the given equation as a new equation in terms of the x and y prime, so that you can successfully draw it in the new coordinate system. So thank you so much for watching, and see you in the next video.